Dear students, in the last module, we have discussed main memory. From today, we will be discussing mass storage and we will follow magnetic systems, optical systems, and flash drives. First of all, we should understand that why we need mass storage systems. You have learned in your previous module that main memory is a volatile memory, which means that the data can be retained in the main memory as soon as we have the light connection. As soon as light goes or there is no electricity, the data is lost. So this kind of property is known as volatile property. But actually, we want to store data permanently for long purposes. So the main memory was volatile memory. We need something non-volatile, which will be served as mass storage. Then the main memory has large memory space. It had more cost, and we also need the ability to remove the memory. But it is very difficult to remove the main memory because we need to open the CPU and then we can get out of it the main memory. But there are some mass storages like flash drive which we can insert into the CPU and we can get out of it externally. So there are different available mass storage systems like magnetic disks, CDs, DVDs, magnetic tapes, and flash drives. And this remained dominated mass storage arena. And today magnetic disks are used and hard disk drives are used. You must have heard about hard disk. That is a form of magnetic system. How it works? So in fact, there is a thin spinning disk with magnetic coating to hold data. And there is a read-write head placed above or below the disk. I will show you in the next slide. And each head traverses a circle called track. So here you can see that there is a read-write head. So from here, the data is being read. And these are the tracks, you can see. And so for example, from here until again going back, this is called one track. And each track you can see have different sectors. So data is read by access arm, which also had a read-write head available here. And disk is moving in this direction. So tracks are normally each track is divided into equal sectors. And sectors have equal number of bits, about 512 bytes to few kilobytes are contained in each sector. And outer tracks contain more information because you can see that outer tracks are comparatively large in the area. So then there is a concept of zone bit recording. So adjacent tracks form some zones. So a typical disk contains 10 zones and all tracks within a zone have equal number of sectors. So if I let you see the zones, so for example, these are the corresponding or adjacent sectors and they can form a zone. So the read-write head coming into this direction can read data from the adjacent sectors. So this reduces the time to read and write the data. Then there are different parameters to assess whether one disk is better or worse than the other. So these are different parameters to gauge the quality of a disk. For example, seek time, rotation, delay, latency time, access time, and transfer rate. So let's define each of the parameter. So first of all is seek time. So seek time is defined as time required to move the read-write heads from one track to another. So for example, you are reading data from one track and there is a command to read another data which is relying on another track. So the time required to move the read-write head to that track is known as seek time. That is noted. So of course that should be less if the disk is considered good. And then there is a rotation delay. So average amount of time required for the desired data to rotate around to the read-write head once the head has been positioned over the desired track. So for example, your read-write head is positioned to the right track, and then you want to locate which data should be fetched first. So that rotation delay, the rotation of your disk, that time is also noted. And when both of these times are added up, they form access time. So the access time should be lower so that your disk could be considered good. And then there is a transfer rate. So you have reached to your particular track with the help of seek time, and then you have identified which data you want to fetch, that is your rotation delay, and then you want to transfer that data from the disk or towards the disk. So that transfer time is known as transfer rate. So this should also be lower so that your disk is considered better. So if we conclude today's module, we have learned about magnetic systems that are under the main heading of mass storage systems, and we have discussed their needs, how they work, and what are the evaluation parameters to assess the quality and performance of the magnetic systems.